Hello, this is Dr. Grafton, and in this video we're going to be covering assignment 3.5, and it's on hypothesis testing. Um, Two ways we can look at data. One of them, we can use the population parameter and look at confidence intervals, and that's what assignment 3.4 was about. In this assignment, we're looking at maybe a particular theory or what we would call a hypothesis that we want to test. And in doing that, uh, as an analyst, you come up with a alternative hypothesis and a null hypothesis. The null is usually the status quo as to what we think it should be. In this particular assignment, then we're looking at a study that was performed uh, to determine the average amount of spent on food in a four-person family in this particular town. They did a random sample of weekly grocery bills of the four-person families, and that's what's reflected in the attached spreadsheet. So assume the national average amount spent on food for a four-person family is $150. That's a clue there. That'll be our mean that we're trying to test our hypothesis against. We're going to use a two-tailed t-distribution, and we're going to show you how to do that in Excel. For the assignment, you need to be able to identify the null and alternative hypothesis. We need to see if the sample evidence is statistically significant, and we're going to use a p-value to look at that. And then we'll also look at a couple of other examples of p-values at the 1% level and at the 10% level. And as normal in these assignments, once you've done the calculations, then you need to come back and analyze that and answer the questions here. Okay. So this is the spreadsheet that you download. It has 100 families that they did. That they look at the food expense for that for each of these families. And so what I did is I created a new tab. Now I didn't do this in your download, so this is something that you can do. Copy what I have here. I just like to organize it in this manner because then I can put the formulas in. If you'll recognize, it's very similar to what we did in 3.4, only it has some other different questions. So the type of alternative hypothesis is a two-tailed test. And basically why it's a two-tailed test is because our hypothesis is going to be, is it going to be equal to something or is it going to be not equal to something? And that's kind of a hint there. If you had a one-tailed test, it would usually be a greater than or a less than, and that would be determined. Your null hypothesis determine what type of test you have. In this case, the assignment's asking for a two-tailed test, so it's going to be either equal to something or not equal to something. And I'll leave that hint there so you can do that for your assignment. So the first thing is we want to look at what the sample size is, and this should be a familiar formula from the 3.4. So we're doing a count. We're going to go back to the data tab. And we're going to do B2 through B101. And that should give us 100 in our sample. We're going to want our sample mean, which is equal average. And again, we're going to back to the data tab. B2 through B101. It left off some parentheses. Uh, I've also went ahead and set the numbers here so it's got three decimal places. You might want to do that for yours as well. All right, the sample standard deviation then. We've done these formulas before. So put point S for sample. Okay. Now we want to do the standard error of the means, which is just B7 divided by the square root of B5. need to put the in here. There we go. As our test statistic basically is going to be a t distribution. So we'll just go ahead and enter it from the how we would if we were to manually do the formula. So it's going to be B6 minus B3 divided by B8. Okay. Then our degrees of freedom is basically 1 minus the sample size. So it's B5 minus 1. All right. Okay. So the we've put the information in. Now we want to know what our p-value might be. So we're going to do the t distribution formula equals t dot dist 0.2t because it's a two-tailed test. ABS returns the absolute value, so there won't be any negative numbers. That's our degrees of freedom. That's our, and here's our degree of freedom is B10. This should give us a p-value. That's a very, very, very small number. You see, I put this one out to 4 decimal places. So based on that p-value, then you're going to have to make a judgment on whether you're going to uh, accept the null or reject the null. And if you reject the null, then you accept the alternate. So it'll be based on what you determine that your null hypothesis is. Okay. All right. So then the next part, it wanted to know what the values would be if you're looking at a p-value of 0.01 or a 0.10. A lot of times when you're making a hypothesis, you'll state what your p-value is. A lot of times it's 0.05. That's a common one. But in this case, it asks for 0.01 or 0.10. So up here, we'll enter the formula then for the t-value. So this is the same formula we had earlier, equal, I'm going to do the inverse. So it's E4 is our probability then, and it's going to be $sign B, $sign 10 is our degrees of freedom. Okay. All right. So that gives us 2.626. Our next one then is our at probability at 0.1 or 10%. Uh, enter our degrees of freedom. This is 1.66. Now we can do a confidence interval here so we can see what our upper and lower limits are. So our lower limit, okay, and our upper limit for the 0.01. Okay, and we'll do the same down here for the other ones. And once you've calculated this data, now you need to look at it and go back and be able to answer the questions on the assignment. Okay, then we'll just do the adding here. You want to be able to compare the sample mean uh, to the upper and lower limits and be able to see what the p-values are, and then be able to make some uh, an answer that to the question then. Okay, so the last one is $B, $3 plus F5 times $B, $8. Okay, oops, the wrong button. There we go. Okay, so that gives you something to do your analysis with. You've got the sample mean, the t statistic, the p-values. You looked at it if you had a p-values of 0.01 or 0.10. Okay. Well, I hope this is helpful, and good luck with the assignment.